Hello, everybody. Good afternoon to some of you. Good morning to others. It's wonderful to see everybody here for our Dartmouth Energy Collaborative Energy Seminar Series, Building a Sustainable, Resilient Future, Perspectives on Buildings and Energy. So this is the fourth session that we'll be having on this topic. And in particular today, we're talking about tools for accelerating carbon-free buildings. And we have a great set of panelists here to talk to you today. I am Alexis Abramson. I'm the Dean of Engineering at the Thayer School of Engineering at Dartmouth. I have a background in energy, in particular in building energy efficiency, and have been working in this area looking at, from the R&D perspective and the market adoption perspective, how we can really accelerate moving forward to improve the efficiency of new and existing buildings. And so I'm delighted to join you today to talk with our panelists about what we can do as companies, as students, as educators, as global citizens to help move things towards a carbon-free world. So in terms of how we're going to run today, we'll have the panelists start off with an introduction, and then I have a few questions that I will ask them, and then please feel free at any time, go ahead and put your questions and answers in the Q&A part of the Zoom interface, and I'll make sure that we'll keep an eye on that, and then we'll have an opportunity to get to questions and answers from you, our audience. So to start us off, I'm going to turn to Kathy Hannon first to introduce herself. And what I've asked our panelists to do is to introduce themselves and then also to share sort of a fun fact, probably about buildings, maybe about energy, and something interesting that just to sort of whet our appetite. So Kathy, let's go ahead and start with you.
Okay, thanks, Alexis. My name is Kathy Hannoun. I'm the founder and president at Dandelion Energy. And we are a startup that's trying to make it much less expensive and simpler to use geothermal heat pumps for heating and cooling in buildings. We're starting with residential buildings, so homes in the Northeast. And for my fun fact, I wanted to share with you a diagram that shows for New York in particular, which is where Dandelion is based, but also I think representative of a lot of cold climate states, how emissions break down across sectors. One thing that was really striking to me when I started getting interested in buildings and renewable energy in buildings is just how large that space heating and water heating those segments are. I mean, look at them compared to, for example, passenger vehicles or electricity generation, and think about all of the resources and talent and money going into passenger vehicles and electricity generation compared to what's focused on buildings. It seems like there's just so much opportunity to make progress in buildings, and it's relatively, I think, underexamined given its impact on climate. So excited to talk with all of you today.
Great point. Thank you, Kathy. Andrew McAllister, I'll turn to you.
Hey, thanks, Alexis. So my name is Andrew McAllister. I'm a Dartmouth 87, and my son is there now as a Dartmouth 25. And I am a commissioner at the California Energy Commission, have been for 9+ years now. And I oversee our buildings and much of our distributed energy programs and policies generally, but the building code and some of the other policies around buildings I oversee. And the building energy code in California is a big deal. I've been in energy since I really was at Dartmouth and right after graduation. So, I think it's really wonderful that the world has sort of woken up to the really primacy of energy as a key issue of our time. My fun fact is, often we think about the operational impact of buildings and how much energy they use and where that energy comes from. And that's absolutely, and mostly what we'll talk about today. but often we overlook the embodied energy in the actual building materials and the construction process. And we've been beginning to dig into that in the California context. I ran across a fun fact. Actually, we hosted a workshop about embodied energy, and it turns out in Denmark, they're a little bit further down the road, and 75% of the carbon footprint of a building is actually incurred during its construction in Denmark. And only 25% is the operational energy throughout its lifetime. So I found that to be a remarkable statistic, and we think in California it's roughly half or maybe a little bit less, but we're working on finding that out.
Great, thank you. Sarah.
Hi, I'm Sarah Ladislaw. I am the Managing Director of the US program at RMI. It is a real pleasure to be with all of you. I didn't go to Dartmouth. My Dartmouth affiliation is I ran track in high school in New Hampshire, and we would have a meet at Dartmouth every year that was particularly painful. So I have some running memories of being in Dartmouth every year. Thanks for having me. RMI is a nonprofit organization designed to transition the energy system to 1.5 degree alignment. And I work on the programs that focus on the United States. But my background is actually broader. I worked for the past 15 years at the Center for Strategic and International Studies, where I ran their energy and climate program. So I also think about global trends as it relates to the different pathways to decarbonization as well. My fun fact, sticking with the New York theme that Kathy introduced, is the building stock is estimated to excuse me, double by 2050, the global building stock in square footage terms. And that is equivalent of building a New York City in building stock every month over the next 40 years, which I just find to be a remarkable statistic, just thinking about the vastness of New York.
Great, thank you. Joe.
All right, so I'm Joe Hagerman. I'm going to share my screen. I have a fun fact / a little bit about me. I am the section head for all the buildings research at Oak Ridge National Lab, and I specifically put my email address in there. So if anybody has interest in working at Oak Ridge or just more curious about what Oak Ridge is up to, just feel free to email me. All the problems that we're facing as a country, as a nation, as a world, it's going to take all of us working together. So please, let's network and share. My fun fact is I'm actually an architect and civil engineer, but I'm here because of Art Rosenfeld, a past CEC chairman. In fact, Andrew sits in the Rosenfeld seat now, right? And Art Rosenfeld is famous for doing a calculation in California that he realized that given California's population growth and people's interest in really large, big refrigerators, that California was going to need many more power plants unless they invested in energy efficiency. So he is really the father of energy efficiency as we know it today. And luckily, I was shaped by my interactions with him, and he had a profound impact on my life. At Oak Ridge, I oversee all the buildings research. We do about $45 million per year for DOE, but my particular research interest is how do we translate demand side management into either grid modernization opportunities, flexibility opportunities, or just to better improve decarbonizing kind of the built environment as we know it.
Great, thank you, Joe.
Thank you.
Well, good. I really, again, appreciate our panelists for being here today and talking to us about carbon-free buildings. So maybe we can start off questions around sort of how are we doing? We heard a little bit of this through our fun facts, but how are we doing on the path toward carbon-free buildings? And sort of, what are you seeing that's happening out there? What trends are you seeing to help move us in that direction? And as you think about that, talking to us about that, thinking about how that might be different, in the US versus in other parts of the globe. So who would like to start us off? Andrew, I'm looking at you. Would you like to start us off? How are we doing?
Well, it kind of, with respect to past practice, I think we're actually doing well because we're changing and updating our building practices. really quite rapidly, actually. And the big kind of trends now are really relying on clean electricity. In California, we have a quite clean grid. It's getting cleaner. It will be completely clean by 2045. And so clearly a core strategy, and I think we all probably agree on this, to decarbonize our buildings in terms of their operation is doing as much with electricity as possible, particularly heat pumps. So Kathy can talk all about that. But heat pumps are both super efficient relative to resistance and gas combustion, and they're using clean electricity, where that clean electricity exists. But I think the part of what we do in the building code and in the various policies in California, promoting load flexibility that Joe mentioned, and really focusing on low energy, low carbon footprint homes, is try to build as much of that into the building code as possible, and really work both in a voluntary way and fundamentally mandatory. That's what the building code's about, but really provides carrots as well for builders to transition their practices, because most buildings are built by most residential buildings are built by production builders, and that's really who we have to get full on board with pivoting their practices, their workforce, their supply chains, everything to go low carbon. I will say I built the home that I'm talking to you now from, and it is a net zero energy building. And I will just personal experience. I had to find a contractor who knew how to build a building like this, and so I think that's our challenge. Is really they're few and far between still. So our challenge is really to pivot the building sector and get them to apply all the technologies that we know are low carbon, load flexibility, make buildings be good citizens on the grid, and allow that reliability impact as well on the grid.
So with that 2045 goal in front of California, how are we doing, Andrew? Then just a quick follow-up, like, are we on track to meet that 2045 goal in California?
Yeah, we're the grid actually turns out it's the easy part. At least the first 80-90% of carbon-free resources, we think we have the technology now, and it's going to happen much quicker than 2045. And then the last 10% or so is tougher. But again, we have a planning process and a bunch of agencies working together to figure that out. And actually the horizon is we're not too far over the horizon here to get there. So I think in general, I think I'm pretty confident that we'll get to zero carbon electricity grid well before 2045. Great.
Sarah, Kathy, Joe, any other thoughts on how we're doing? Joe, go ahead.
I would just like to say that I think, to get us there, it's like, you could present it as a problem, as a challenge, like we got to do this as a country, or you could present it as an opportunity, right? And to me, it's an opportunity for, U.S. companies to innovate, to use science. We have the wherewithal to kind of solve these problems. That's why I'm encouraged by, like, Kathy's business is a perfect example of that, right? There's these new opportunities that are presenting themselves for new businesses to get started, for new entrance into the building sector that you would normally not traditionally think of, right? So I see it not as a problem, but as a huge opportunity for the country as a whole.
Great, good.
I wanted to respond to something Andrew mentioned. So first of all, it's obviously incredibly encouraging to hear your estimates for the cleaning up the grid. But one thing you mentioned was just converting the sector over, the builders, the contractors, the supply chains. And I do think that that is the heart of the challenge in terms of converting our buildings. A lot of people correctly point out heat pump technology exists. Certainly geothermal heat pumps have existed, air source heat pumps have existed for decades, both. But there's, I think, a lot of the reason that we haven't gotten farther than we have is because it's not easy enough. It's not simple enough for everyone to adopt. It's not simple enough to do it well, and it's more expensive than it needs to be. It's like all of these practical issues still stand in the way. And I obviously very much believe they can be overcome, which is the only reason I started a company to do heat pumps. But I do think those are the challenges in front of us. And so, a lot of the time we spend is just thinking about how do we make this as easy as installing a gas furnace or an oil boiler, because it kind of needs to be, it needs to be as easy or easier if we're going to see the uptake that we need to see.
Great point. Sarah, maybe you can pick up a little bit on those big challenges that we're facing. What are you seeing in your work with RMI in terms of what those big challenges are in front of us that we need to overcome in order to achieve a vision of carbon free?
Yeah, I think, thinking about this both from a US and an international perspective, it's really important to appreciate the fact that our energy system and decarbonizing the energy system is about solving for a systems problem, not a individual technology or individual sector problem. But a lot of the strategies that are required to get there do require you to have sector-based strategies, obviously. And what I'm encouraged about is we're now not just thinking about buildings on their own, but about their interaction with this broader decarbonization of a system. And it is important for, the reason that like the vast majority of, energy demand in the future will be coming from like urban settings. And in those urban settings, the urban, energy use is going to come from buildings. And so thinking about how buildings kind of fit into the decarbonization of a city is going to be hugely important, particularly in the building stock that is yet to be built in many developing countries around the world. And so I do think our conversation about buildings and their role in this broader system has really become much more sophisticated in the last 5 to 10 years. And we are now starting to appreciate like all of the component pieces that will have to be addressed, and the fact that like the solutions will be very different depending on the places where you are. And so it's just become a much more sophisticated conversation, which is always a good thing when, it means we are capable of thinking on multiple planes here. And that's great.
Yeah, as somebody who has spent a lot of time focused on technology and the complexities of, thinking about heat pumps and heat exchangers and compressors and how you do this in cold climates, right? That's nothing compared to, I think, what you just said, which is the multi-level, multidisciplinary complexity of doing this, with that broad strategy in mind. We got a question from the audience. Maybe it'd be good for us to spend a little time sort of what's our working definition of what we mean when we say carbon free? Do we literally mean no, like zero emissions, the carbon equivalent of emissions? Or when you talk about the carbon free or net zero or zero energy, how do you define that in the roles that you have?
I can start. And I'm sure it will be different for all of us, but from my perspective, our mission at Dandelion is no point source emissions from heating. So if we can put a heat pump in, even if that heat pump is using electricity, now it is up to others like Andrew and others to clean up the grid and get rid of those emissions. But with geothermal, it's about 80% renewable energy from the ground and 20% energy from the grid to heat and cool homes. So we're taking care of a lot of the problem and then electrifying so that the grid decarbonization can take care of the rest.
Great, thanks. Others, Joe?
Yeah, I mean, we maybe take a slightly different position than that, just because we understand that, there's like pathways to get to net zero kind of future that we hope to get to. But in the short term, what we're trying to do is study how much maybe backup emergency natural gas you might need in a cold climate, and then sequester that amount over the year to say that building's net zero carbon, right? So that's sort of a short-term pathway, we believe. And so we're also pioneering trying to utilize building equipment to actually be a carbon capture mechanism as well.
Great. Attacking it from all angles. Yeah.
That's right.
Great.
I'll just maybe make just an observation. For a long time, the focus was on zero net energy, sort of not push, basically having a building that sort of could persist on its own, more or less. But that was never really the case, right? Because you're always pushing and pulling electricity from the grid. So, unless you're willing to cut that cord, you're not going to be truly zero net sort of at any given moment. And so once you sort of realize that, it doesn't actually matter where the generation is per se, whether it's on the roof or out on the grid or whatever, as long as it's clean, that's what you're really interested in. And then you can pivot toward having carbon be your primary metric. And so the zero net carbon is really where we're headed. And I think there are a number of similar but different strategies for doing that. And so, how much sequestration, where is that sequestration, at what scale? Whether, then there are varying opinions about that, depending on sort of what advocates or, officials you talk to. So that's an ongoing discussion, actually, what sort of the structure of a zero carbon energy system is really going to look like.
Yeah, and having different strategies for different places is important. So Andrew, maybe we can pick up a little bit on what you were talking about earlier as it relates to this too. So you've told us a little bit what California is doing in this great 2045 goal. Can you talk more broadly about what's going on in the US? And maybe I think of California as being a leader in this area, right? So how do we help entice other states, right, to kind of follow California's lead in one way or another?
Well, thanks for the question. I always appreciate when people say, "Oh, California is the leader." In fact, and that is true in many areas. And I do sit in Art Rosenfeld's chair, and we have Berkeley Lab, no slight to ORNL, who does a lot of building energy efficiency work. But New York is doing a lot of amazing things. I mean, they've got a really good legislative structure now in place and goals. Massachusetts, Hawaii is doing some amazing things, even though they have a pretty unique context. So the Pacific Northwest is doing, there really are advancements going on all over. Even the South, where you have a primacy of electricity, you don't have as much gas distribution. They're doing a lot of really wonderful things with electricity. So I don't want to sort of claim this whole field as California's, because it's not. I think what we're focused on, we have a bunch of tools that are statutorily enabled. The law says we have these authorities, and the building code is a big one. We also can do appliance efficiency standards to the extent that the Department of Energy and the federal government is not doing them. But we work with them very closely. The existing buildings, I think, I want to absolutely make sure that we talk about that, because most of the buildings that will be here in 2050 are already here. And most of them have, in California, 90% of them have both natural gas and electricity service. And so getting into those buildings is where I think we all really need to work together. And we need, better information, better data from the utilities, better sort of information. We're working on all of that stuff to really get, to help inform policy, to really target, low income and target the places where there are the most savings available. I think that, taking advantage of the digital economy and sort of the information economy to really do better policy is one thing. And that's going to be different, depending on what state you're in, where you are in the world. But I think in California, 80% of the emissions from buildings comes from heating, water heating or space heating, and the residential buildings. And we can have a different conversation about commercial, which are more electrified already. But in residential, if you can get a heat pump water heater and a heat pump HVAC system, then you've cut out 80% of the emissions. And so what we're focused on is really creating a plan to get into those buildings, to have public-private partnerships, to get the financing. And, it's going to take in California roughly $100 billion to retrofit most of our existing residential buildings. So that's a big, big number. That's on par with the whole capital base of both the electric and gas utilities in the state. So we're talking a big generational shift. And I think if I have sort of one big recommendation, it's those conversations need to take place in public. What are we going to do with our existing gas system to reduce its carbon footprint? And how are we going to pivot many of those loads over to clean electricity? And that's a part of the social compact, really. I'm sort of elevating this to the biggest scale here, but it's all about getting resources to the contractors, to the OEMs who make the equipment, the distributors, to get them there, to have them on the truck, and just really make it part of the ether, so that whenever there's a burnout, whenever there's a device that needs replacing, that it gets replaced with the lowest carbon technology that we have available. And we have the technologies. That's the thing. And then layering on that, what we're doing now is just making sure that load flexibility is native in as many products as we can, so that when the grid needs some flex, that it has hundreds of it has millions of devices out there that can actually flex.
Great. Yeah, no, great points. And you're really sort of hitting it home, right? It's a technology play. There's also the policy piece, and they really have to work together in order to make this all happen. We had a couple of questions around strategies for new building stock versus retrofit buildings. And Andrew, you mentioned, I think it's right, 2050, if we think of 2050 as a goal, right, 60% of the buildings or thereabouts will be existing. So we definitely have to focus on existing. There's also a question around how much emissions come from residential as opposed to commercial. And, looking at IEA numbers, again, about 60 or so % of the square footage is on residential, maybe a little bit higher expectation in the future is what I know IEA projects to happen. So it's really a both and, right? It's not like it's so focused on existing or so focused on new. We've really got to be focused on both existing and new, and we have to be focused on residential and commercial as well. So maybe we can dive a little bit more into the technology piece. And Kathy, you are founder and president of Dandelion, which builds and installs home geothermal systems. Can you talk us a little bit more about these like innovative heating and cooling solutions that are so important for our future? And what's kind of getting in the way of us adopting these so that we can move forward?
Yes. So I think a lot of us agree that heat pumps are probably going to be a large part of the solution, just because they're an electrified way of heating and cooling and much more efficient than electric resistance. And then some buildings and some climates are well suited for air source. And at Dandelion, we think ground source can play a role as well. And the reason that I started a company to focus on ground source to start is because the ground being the same temperature year round really helps you out with when it gets cold, you just have the ground. So it takes care of the debate about capacity at low temperatures, right? You can just replace the full fossil system with the ground source heating system, and it will work without a backup. And also, very critically, we saw that in the Northeast, where a lot of people have fuel oil, it's possible to make a solar type of value proposition work for homeowners. So you can say, look, we will 100% replace your fuel oil or propane system with a brand new geothermal system. And if we finance that for you, your cost to pay back that loan plus the cost to operate the geothermal system is still less than what you were paying for fuel oil before. So it's just like financially in the customer's best interest to do it. So to answer your question about what's holding us back is we can make that work right now today. And we have, many customers in the Northeast with fuel oil and propane using homeowners who have homes that are like well suited for heat pumps. We can dive into the details to whatever level we want to, but some homes it's easier to retrofit them with heat pumps than others. And I think our challenge is just constantly expanding the types of homes that we can cost effectively retrofit with heat pumps, and then getting the cost down low enough that not only can we undercut the cost of oil and propane and make it in the homeowner's best interest, but clearly we also need to eventually undercut gas. And just to get specific, like some of the key challenges that we're working on today at Dandelion, we're working to make heat pump products that don't require homes to upgrade their electrical systems in order to accommodate them. So it turns out that a lot of the cost of converting to heat pumps isn't the actual heat pump. It's like all the things you need to do to the house to make it work well with the heat pump. So heat pumps that don't require you to upgrade your electrical capacity. And we're working to create a heat pump that doesn't require homeowners to change their ductwork. So this, again, I don't know if this is too specific, but because furnaces heat air to a much higher temperature than heat pumps, you need smaller ductwork to distribute that heat throughout your house. And that's a huge problem for converting to any sort of heat pump, because changing your ductwork is really expensive and it basically makes it not feasible for a lot of homes. So if we can create heat pumps that act more like furnaces and boilers to the home, it becomes more of a swap in, swap out situation that's not only less expensive for the homeowner, but will make it easier for contractors to adopt this, because you don't have to know how, you don't have to do as many things to make that switch. You don't have to be as good at electrical or ductwork to have your heat pump work well. And then the last thing I'll say, and then I'll let other panelists weigh in, but I think one advantage of geothermal as well is that while we do often recommend insulating homes and sealing homes because it's just good in general, you don't have to do it as much as you would for another type of heat pump to make the system work well. And I think that optionality, again, it's like, it just makes more homeowners likely to say yes to doing it, which is our goal. And the challenge with geothermal that, of course, is such a huge focus for us is getting that ground loop in the ground is expensive and difficult. And there's not a huge labor force of geothermal drillers to say the least. So I think our opportunity, to use Joe's word for it, is innovating when it comes to that ground loop and that heat exchange with the ground, and seeing, like, as we bring the cost of that down and make that simpler, we will just be in a much better position to go after gas, for example.
That's great. I mean, it's great to hear that there's innovation in this space, and it's really important for a lot of reasons. There's a question from the audience that's asking, Kathy, when will Dandelion come to the Upper Valley / Dartmouth area?
Yes. Well, one of my most personal goals for Dandelion is to be able to serve the great state of New Hampshire, where I was born and raised. So it will be such a fantastic day for me when we're able to do that. And we're getting there. So we have opened up part of Vermont, Massachusetts. We're working on servicing all of Massachusetts. So it's only a matter of time till we're able to cross into New Hampshire.
Well, I bet we have some very eager soon-to-be graduates of Dartmouth that would love to help you do that. So good. How about we stay on the technology theme a little bit? Joe, you lead the Building Technologies Research section at Oak Ridge, and I know that research and innovation are so critical, right, to meeting those building efficiency goals. Can you talk more about other technologies that are on the horizon? You mentioned a few, and a few have come up, but some of your favorite technologies, maybe, let's say, on the horizon here.
Absolutely, sure. And thank you for the question. But first, let me just add to what Kathy said. We are working on a lot of those heat pump issues at Oak Ridge. Oak Ridge is the U.S. Department of Energy's heat pump lab. So we pioneered the heat pump water heater that we know about today. And now we're also trying to scale it, as Kathy said, so we don't have to upgrade the service panel at a home, right, that may have traditionally had natural gas. So as we go to these electrified solutions, sometimes the capacity is a little bit larger. So we have to deal with that. But yeah, to your question about the other kind of cool stuff that we're doing here, I'm going to share my screen real quick to show you a quick little slide that I put together of sort of two big technologies. The first one is we're using rooftop air conditioning systems as direct air capture devices. We know them as decentralized direct air capture devices. And that, I say decentralized because these rooftop units are, scattered across just about all commercial buildings. So if you're flying in and you land at an airport, you look out at all the tops of the buildings, you see these little white dog houses everywhere on top of a building. Those are rooftop units. And what we're using is we're co-opting those those devices and putting in new materials, so new filters, new rotating wheels. So they're called desiccant wheels traditionally, but we use those as mechanisms to put new materials into the airstream, where we're able to capture the CO2 that people emit in the building. So we're making the air inside the building cleaner, and then requiring less fresh air to be brought in. At the same time, we're capturing that CO2. So the big question is, all right, you got a bunch of CO2 there on top of a building, what are you going to do with it, right? So at the very bottom, I've kind of really talked through the kind of science, technology, and policy considerations that you have to walk through as you decarbonize a building. So as a business as usual building, you have on the far left, you have natural gas and electricity coming in. You have a lot of fresh air coming in, and then you have exhaust air, CO2 going out, or exhaust from the natural gas being burned going out. That's business as usual. A traditional decarbonization solution would just say, hey, cut the natural gas out of that equation. And you have less CO2 kind of from the combustion of the natural gas. You still have to bring the fresh air in, you still have to bring electricity in. You're still accessing or exhausting some CO2. Well, once you use decentralized direct air capture, we're able to capture the CO2, reduce the amount of CO2, fresh air coming in, reduce the amount of CO2 that's being exhausted. And then we're able to take that CO2 and then maybe combine it with some hydrogen to make a hydrogenated renewable fuel, where we're actually turning that natural gas line back in to actually deliver that renewable fuel to a higher use that maybe have some centralized direct air capture from the exhaust, right? So this is where ideas taking kind of buildings as natural gas takers, so people taking natural gas into natural gas makers, right? So that's the kind of science, technology, policy framework or continuum that we're working on. And then I've added another slide here, just on the right hand. We're also doing a lot of work with concrete. So we've made some concrete with 15% less embodied energy, and then reduced in the amount of concrete that's actually in production as well, without any kind of updates into the capital investments of a concrete plant, right? This is a precast concrete plant. And I throw this in, the concrete as a sector, steel as a sector, all these commodities as sectors are the ones that we need to decarbonize as a whole. And so I pulled a report. This is the clean and competitive report for US manufacturers to get to your industrial efficiency and carbon question you asked earlier. This is really a roadmap on how the country could use science and scaling up a lot of these building solutions and applying them in the industry to really help decarbonize the industry. And that's from the ITIF Foundation. So that kind of gives you a good spectrum or two bookends that we're trying to deal with. We're dealing with some on the materials and then a lot on the equipment side, because that's our core capability here at the lab.
Very neat stuff. It's great to see that the national labs and others are working on this. What comes to mind though, Joe, it has to do with cost effectiveness, and Kathy
Sure.
touched on this a bit, right? So when you look at some of those solutions that you're working at, how much is cost effectiveness part of the equation, right? And there was a question in here around, can we really progress if the money side does not support best practices, right? So if we think about the financial side, how does that enter into sort of the research considerations and then
Sure.
the implementation and the market adoption and thinking about that aspect?
Sure, right. So great question. And at first, we're just trying to, at a laboratory scale, just prove out if some of these ideas just work, right? So that's part of our core business. Another part of our core business is actually working for or with industry, right? So a lot of the companies that we work with have cooperative research and development agreements where they may not be able to solve a problem. So they reach out to the national labs, and then DOE invests our time to go help those companies, right? All of our projects are really tied to some performance targets. So the direct air carbon capture solution that you saw there, I'm not going to talk about the capital improvements that you need to actually enable that, but we look at it on, making sure that you can capture that carbon and only have a 5% penalty on the increased annual energy consumption of the unit. So that's the metric that we're going off of now. But I think as we go forward as a society, once we have, a carbon, some type of monetization of carbon in our everyday life, whether that's the social cost of carbon, a carbon tax, those kind of effects start to, really incentivize these solutions to really come into the market, right?
Right.
I know that as a whole, since we work with just about all the US manufacturers of air conditioning equipment, they're very interested in these technologies because it's just an incremental cost to actually, capture that CO2, and then you have to deal with the CO2, which is a separate issue. But they're really interested in that dual purpose or that multifunctionality of the equipment that we enable, right?
Got it. Great. Thank you. Wait, maybe one more technology question, then we're going to go back to the systems level and get Sarah in on the conversation a little more. So the question came from the audience. What are your thoughts on the use of nuclear energy as a replacement for fossil fuels? Any comments on that? Any of you?
I'll jump in real quick by just saying, obviously there's a huge range of spectrum about nuclear. In California, it's actually illegal, so we will not have any new nuclear plants with statute that prevents that. But there are states looking at these smaller modular reactors, and we may see some of that in the future. The question asked, is it too expensive? And just as a social phenomenon, it's really hard to get nuclear built. And so that jacks up costs and stretches out timelines in a way that does actually make it largely cost non-competitive at this moment. So unless there's a kind of a change here, it's hard to see too much nuclear coming online, but who knows?
Great. Good. Thanks. All right. Well, let's kind of take that step back up and think about the system side and think about that global impact. So Sarah, you are the managing director of RMI. And RMI is focused, Rocky Mountain Institute is focused on working with industry, governments, NGOs, and the public to really help us transform how we're producing and using energy. So maybe you can talk to us more about what the US and global governments are doing to tackle climate change, particularly in the building sector. And we have a question from the audience here too, maybe an example from even Africa or Asia and how maybe that's different than how we in the US might be looking at some of the solutions.
Yeah, sure, absolutely. And it's a super appropriate set of questions given the fact that we've got COP26 going on and we've got some major legislation maybe passing in the United States. All of this is like some important leaps forward in the sort of broader narrative about where we stand relative to the challenge. I will say, there's what I said before, I think is the sort of key interesting point for me. If we take just a big step back and say, okay, well, what was the decarbonization challenge that we've been thinking about for the last several decades? And like, what was our theory of how that was going to come into being? And a lot of it was really about dropping the cost of electric power technologies, right? And like, we've done that really successfully. And that's a really, really good news story. Now we have a lot of integration challenges, right? It is about taking and implementing and deploying those technologies as quickly as possible, integrating them into a grid in a way that the grid can be additionally reliable, and then electrifying end use sectors, right? So when you think about like this buildings challenge that we've been talking about, a huge portion of that buildings challenge does come outside the building sector, which is in dropping the carbon in the electric power sector. And then it comes in, some of what we've been talking about in terms of electrifying the buildings and the uses in the buildings themselves. And then there's an efficiency challenge within the building. And then there's also this like really important digital component, right? So like, and you're starting to see places in the United States, in Europe, and a couple of other places like really helping the building learn how to be responsive to the humans that are using it, and then the grid that needs it, right? So like, it's a sort of an awakening of this like integrated system that is super important for being able to tackle that challenge. And I think what's been really interesting and what you see a lot of the focus on, particularly what we do at RMI and here in the United States, is we can reach those sort of, integration challenges and test them out and understand them in new and more important ways that like feed back into this loop of, okay, now that we understand what that eventual vision looks like, how do we lower the costs of people actually getting involved. And some of those are hard costs and some of them are soft costs that I thought Kathy did a really nice job of like outlining, which is like, it's just a pain and people don't know how to do it. And like, we need to stop making it a pain and people not knowing how to do it, or we need to mandate that they have to. And there's like always a delicate balance in there. And so we are seeing lots of, sort of innovations on that front to try and really make it so that this is, not seen as a burden and something people don't know how to do, but seen as an opportunity that people are like, hey, you know what, like all the fancy schmancy buildings that are being built can do these new fun things. Like we need to be able to make sure that that is available to more people more often with less of a sort of like an upfront threshold cost. So I think that on the one hand, there's like a lot of really interesting things going on that sort of like high tech integration side. Going back to sort of, what the issue here, right, is that we have, a goal of getting to net zero in this building space by 2050, but we also have to like double the energy services and like double the footprint, right? So it is a very big challenge. And in a lot of the places where that needs to happen, they don't have that building stock yet. And so what's interesting is not thinking about, what is oftentimes like a developed country challenge, which is how do you take the building stock that you have that you don't really renovate as often as you should and need to accelerate that renovation process and sort of test out these new technologies. Well, in developing countries, you need to build as fast as you can. And so lots of different strategies about, how do you incorporate like local content that can drop the embedded carbon of those buildings? Like, how do you do that? Not just from a policy push standpoint, but just from a better design standpoint. Like how much, passive heating and cooling can you embed in that design? How do you build your cities so that like the complementarity of those buildings like doesn't exacerbate the problem for the cities as opposed to like make the city sort of function better? How do you think about, in places where we have lots and lots of places where, you have additional codes and standards for buildings, but, in sub-Saharan Africa, there are not a lot of codes and standards, even voluntary ones. Like, how do you incentivize that behavior when that type of, policy front hasn't expanded yet? And so I do think what has been really interesting is I was looking at some reports before this. We've actually seen sort of, really good progress in terms of the number of countries around the world that are putting forward buildings as a component part of their nationally determined contributions. And which is great, but like the vast majority of the way that buildings show up in country pledges about what they're going to do is about building efficiency, not about building content, right? Like not the embedded carbon and some of those other issues. So, and there's a number of countries for whom they don't have sort of the codes and the standards that are, really required or not required, but really important for sending signals about like what is actually good. Like what is a good standard and how do you, think about some of those things? And I think this is one of those areas, again, where just information about building stocks, just things that like, I'm a big fan of this report that Johnson Controls people do every year, which just basically looks at all the building investors, and companies around the world and says like, what actually matters for making you do things that are more efficient or more carbon conscious in the buildings or, in the factories that you build. And a big part of that is like just understanding like benchmarking and disclosures of like different, characteristics of different buildings or thinking about building codes and equipment standards. And without that information and understanding like the context in which you work or having those standards, it's kind of hard to, just make those investments based on, the cost benefit analysis of like what you would be doing, because there's just not that sort of broad-based signal. One of the other questions, I do think like the sort of second tier of things that are really important for determining those investors are like do you have like owner tenant agreements, and do you have innovative financial mechanisms to try and like communicate and spread and talk about the costs of some of these investments, whether it's on the equipment and appliances side or on the sort of, like building upgrade and efficiency side. How do how do we spread these sort of, more sophisticated financial tools as far and as wide as we can, so that those costs can be spread out, so that, they're easier to bear. And then I would say the sort of last piece, which we tend to think of first sometimes, is just like financial incentives, right? Like, do we have financial incentives, tax rebates, tax incentives to be able to do, a lot of the things that get us to a sort of a zero carbon building environment. And really pleased to see, that at least in the US legislation that we're seeing now, there's a bunch of this, right? There's a lot more focus on homes and residential and built environment incentives. And then also on sort of greening of materials, right? Where you have some industrial emissions component pieces there. So all in all, I feel pretty positive about, like the fact that we're having much better and more sophisticated conversations about the differences in the approaches that are required to manage this part of this larger systems challenge. I'll stop there, but those are just some of the things I was thinking about.
Great. That's great examples of how we will continue to have an impact in these areas. Maybe I can pick one thread there, and that's the codes and standards, right? Building codes and like appliance efficiency standards, which have been shown, at least in the US, right, and beyond, to have a real impact on saving energy. So and as you mentioned, in sub-Saharan Africa, right, that is right there, those kinds of things haven't necessarily been adopted, right? How do we help those different countries, right, those areas of the world, right, see the benefit of codes and standards, just as an example, and help them sort of find ways to start adopting them in their parts of the world because of the potential impact that they can have?
Yeah, I think there's probably, two directions to do this from. And one is, we do have international code setting conversations. And the more we sort of continue to take what we know about what is possible and advance that into the code system for developed and developing countries, I think that's really important, right? It sends a signal about what the art of the possible is and where we should be going. And so I think that is one sort of like very high level type thing that is important for raising the bar for everybody, so that we continue to progress and sort of pull everybody, even portions of the developed world, along in this conversation. I do think the second piece is having really solid examples of, built infrastructure, these case studies and built infrastructure in developing country contexts that show what it means to just, to achieve what is possible in the context of that particular local environment. It matters a lot, right? I mean, whether it's, thinking about integration into distributed energy systems, or whether it's in, a particular urban environment, being able to have those examples so that others can see what that looks like is really important. Because I think if not, I'm a bit of an academic, right? And like all my figures and numbers and stuff, they don't really actually matter unless somebody can see what it looks like in their neighborhood, in their community, and figure out, okay, well, how do we take that example for this particular environment and scale it? Right. And I think there's just a huge amount of activity now that's going on in that space that is designed to try and bring those learnings forward as quickly as possible. I have no doubt in my mind that if we had all the time in the world to tackle this challenge, we would be heading in the very same direction that we are, because it's better. There are better outcomes for people and their families and their economy and all of those things. The problem is we have to do it really fast. And so I think the doing it faster piece is where a lot of those challenges come in. And I will say, I do think it's important. One thing that we have overlooked in a lot of these conversations is like in the standard setting or in thinking about the built environment, particularly in developing economies, we're going to have to do this with a mind towards, the impacts of climate change that we're seeing at the same time, right? And so I think that by bringing both the sort of zero carbon and the more resilient pieces, we can have a better story, right? Zero carbon seems luxurious sometimes when you're working in some of these countries, but if you're talking about not only, fewer emissions, lower sort of like ongoing energy bills, but then also like a more resilient built infrastructure in the face of what we know and are seeing in the climate right now, I think we can have a very sort of durable sets of examples that will catalyze additional investments.
Thank you, Sarah. We've got some other questions here. Unfortunately, we're not going to be able to get to all of them, all the remaining ones, but I think we touched on quite a few. I'm going to do really quick, combine maybe two of the questions, and that's around your professions and workforce. So there's one question in here about, well, we also need the workforce trained, and the example given was on the geothermal side, to have technicians out there to help service my ground source heat pump. There's also, what if there are students in the audience or kids in the audience who are interested in going into the energy field? So any quick words of wisdom on workforce and profession and the energy professions that you'd like to share before we say goodbye to everyone?
Yeah, I mean, I think the example that the questioner asked about, they have a geothermal system for their radiators, but because it's radiators, they needed a backup oil furnace, and then it's hard to find somebody who can service such a complicated setup. I think it's a perfect example of why we need to simplify the technology, because I think it will be very hard to train a workforce that can do very complicated things at scale. So I think that's a great example. But also, yes, lots of need for more people to join energy companies. And I think luckily right now we're seeing sort of a lot of companies get started, a lot of existing companies start to invest in renewable things, like car companies going into electric, for example. So I think it's a great time to be getting into the sector, because there seem to be so many jobs available, and just in general in this economy, so many people looking to hire. So a great combination to get involved.
I wanted to make a comment on this as well. So, we need workforce up and down the whole value chain, from the design and the OEM manufacturing all the way down to the install. And I see this as a huge opportunity. Every year, the National Association of State Energy Officials has been involved in this. The DOE now took it back, but there's a energy and employment report that actually for the nation, and they drill into some states. And, energy efficiency is a huge generator of jobs. And so that could double, triple, quadruple if we got on the stick and really focused on retrofitting our existing buildings. It could be a massive job generator. And we're going to have 3 times the electric load, 20, 30 years from now that we have today, because of electrification of transportation and because of electrification of buildings. And so that also is a huge opportunity to upgrade the grid, which also generates jobs. So the labor community actually is quite sophisticated in this realm, labor with kind of a big L. And they have training centers all over California that actually do amazing work, bringing, installers, contractors, technicians, of all the different licenses and trades into the digital economy to be able to do these kinds of projects. And I'm actually quite optimistic that if the projects existed, the labor would train up and be there very, very quickly, actually. If we need to, it's a push and pull both that we need.
Great. Thank you. We're going to have to end it there because we've reached 1:15. I just want to say thank you again to Andrew and Sarah and Joe and Kathy for being with us today and sharing your wisdom. I thought I'd stop with a quick sort of look over there. There's the front lawn of the construction project, which is the Irving Institute of Energy and Society, a great, wonderfully energy efficient new building that will be joining us on the Dartmouth campus soon. Hope to see you 4 of you to come for a visit, and those in our audience too. So thank you and have a great afternoon.
Thanks, everyone.
Thank you.
Thanks.